Okay, final for real. Sige, since na-extend naman na-move naman yung LE, I'll just make an updated version, a more refined version. Kasi didn't really like the quality of the previous one. Just give me a bit. Okay, sige, let's start. Okay. So, same Samplex, pero I think I'll just do more justice with the explanations for this one. Okay. This is the term in the Candeli notation that describes the maximum number of potential customers of the queuing system. So the keyword here is potential customers, meaning the ones that could and all the people that could enter the queuing system. So this is um this is simply calling population. So recall na lang yung full notation is the arrival, distribution, the serving distribution, number of servers, queuing discipline, uh, calling population, ay, system capacity, then calling population. So this is just calling population. Okay. Number two, true or false, the minimum number of servers of any queuing system is one. Answer to that is true, simply because wala kang queue without servers. So you can't have transitions between, if you define your states as number of customers in the system, you cannot have transitions from a higher state number of people to a lower number of people if there's no one to serve them. So minimum number of servers is one. True or false, for any a queuing system with finite capacity will never explode. The answer to this is true. Because even if uh, is greater than one, at n equals k, which is system capacity, becomes zero, meaning you will never go beyond that many people in the queuing system. So parang never siya magiging possibility, and therefore hindi siya magiging tawag nun, hindi siya mag-explode basically. Wait, check ko lang ulit. Make sure okay, unmuted, screen sharing. Buti naman. Oh, no video pa. Well, not necessary pa naman. Pero turn it on na rin. Okay. Number 4. Um, True or false, for any queuing system, the percent utilization of the servers is a proportion of time that all servers are busy. The answer to that is false, and what makes it false is all. The replacement should be any server, not all. So this is false. Um, the term in the candle denotation that describes the prioritization of service for customers in the queuing system. This is just queuing discipline. So just refers to whether or not how the customers are served. So the two that are exposed to at the moment is first come first serve, FCFS, and GD, which is general discipline. GD just means na the queue, that it doesn't really matter what queuing discipline you have in the queue. Those equations will still hold, regardless if it's first come first serve. 6, the Poisson process is derived from the Bernoulli process. What assumption of the Poisson process allows for this approximation? What allows for this approximation is the infinitesimally small intervals. What this just simply means is that yung intervals ng arrival is infinitely small. So if this is your timeline, you can never have two simultaneous arrivals. They have to have some amount of distance between them, no matter how small. The reason why you can approximate the Bernoulli process because of that is um, the Bernoulli process we call is basically success or failure. So it either happens or it doesn't. So you have to remove the case where it can happen twice, right, in a specific instant of time. TLDR, um, it's not so important naman na to us given our exam format. Pero yeah, TLDR is just it can't allow for more than one thing to happen at the same time. And therefore, yung result mo at any point in time is 1 or 0. Which is why you can derive the Poisson process from the Bernoulli process, given this assumption. So that's for 6. 7, given an M1 FCFS infinite infinite with lambda equals 6 per hour and mu equals 9 per hour, what proportion of customers will not stay for more than 30 minutes in the system? So this is where you're treating W as a variable of sorts, as a parameter, sorry. So recall na kapag rate or kapag number of occurrences in a given time, we use uh, Poisson, right? Which is, if I'm not mistaken, uh, this is the PMF of a Poisson. If we want to get naman the number of the amount of time between occurrences, then we use exponential distribution, which is 1 over e raised to. So you might think, oh, may lambda na given, pa-plug ko lang. Not necessarily, kasi what we're checking is the amount of time that the customer stays within the system, right? So our parameter for that therefore is W. Bakit W? Because this is the amount of time that a customer on average stays inside the system, and that's what you want to find, right? So given that, hanapin natin si W. So this is an MM1 FCFS infinite infinite. We have an equation for that, which is this. Our W is given by 1 over mu, which is 9, and lambda, which is 6. So just recall this is per hour. So we have to be very wary of our um so 1/3 hour ito. So next, what we're gonna do is essentially plug it in. So yung mangyayari dyan is okay. So this is our hours per customer. Now lambda here is our rate, right? This is our rate. Meaning, so correction, sorry. We're not really plugging in W, but we get the lambda from W. And to convert this into a rate, we have to, so our effectively our lambda here is 3 customers per hour, right? So then this is the rate of the time that this is the rate that describes the amount of time that the customers spend within the system. So this factors in queuing, this factors in service as well. So this is different from the arrival rate, and it's also different from the service rate for that reason, right? So we can now use our calc to derive yung, check ko lang if kita siya, to derive yung ano, percentage. So the probability that a customer spends, what's the wording of the question? The wording of the questions will not stay for more than 30 minutes. So that's very confusing. Pero essentially, they will stay for less than 30 minutes. Right? So x 30 is equal to 1 minus, uh, oh, careful dito. 30 minutes, naging 1/2 hour. 1 minus e negative 3, which is our lambda, and then 1/2. Plugging this in, I hope this is visible. Ayan. Gives us 0.77686. So, 4 decimal rule, 6. So that's our answer. That's the proportion of customers that will spend less than 30 minutes in the system. Okay. So that's for 7. 8. Let's go. Let's go to 8. 8. Give the term for the queuing attitude when a customer switches between alternate queues. This is LE4 pa, but this is jockeying. Give this the term for the queuing attitude wherein a customer already in a queue leaves the system without being served. This is reneging. Again, LE4 pa to. Give an example of an MM infinite FCFS infinite infinite. This is anything that is, this is just the definition for self-service queues. Just a reminder na, like, hindi siya yung self-service as in yung kiosks, for example. Because obviously those, like, you still have a finite amount of kiosks. So by self-service, as in, parang you're not dependent on the physical limitation of the building or of the facility, right? To be able to serve yourself. So for example, G-Form is actually one example of a self-service queue. Kasi theoretically, I mean, obviously may physical limit siya, like from a computing perspective. Pero technically, pretty much infinite yung masaserve ng isang G-form, right? Like, as many people can answer it simultaneously. So yeah. Okay. Let's move on. So that's number 1. Problem 1. Problem 2. Philemon owns a liquor company that solely produces a 50-year single malt Scotch whiskey named Phil's. So I think let's just start highlighting para tipid yung time. I don't know what they'll use it for yet. Kunyari. The process to make a market-ready bottle of Phil's involves the preparation of raw materials for aging. This is done outside warehouses. And then aging the materials in containers for an average of 50 years. All aging containers are located inside warehouses. Only then is the bottle deemed market ready and shipped from the warehouse to retailers. There is no limit to the containers that the company uses for aging. Each day, the company is able to begin the aging process for 2 bottles worth of Phil's Poson distributed. If a warehouse can hold 3,500 bottles worth of Phil's by volume for aging, at least how many warehouses should the company have to sustain its production reliably? Assume 365 days in a year. Okay, so judging from the system, based on the common formulas we know, so first clue natin is there's no limit to the containers that the company uses for aging, so we likely have infinite number of servers. The second clue that we have is that walang sinabing holding area before papasok yung bottles into warehouses, because the warehouses is our concern. Why is the warehouses our concern? Because if you look at it, based on the problem, if this is the warehouse, may information tayo na may pumapasok dito na 2 per day. Kasi as you can see, each day the company is able to begin the aging process for 2 bottles. And then may sinabi rin dito na it effectively you produce one every 50 years, or like it takes 50 years to make. So yung rate mo is essentially 1/50 years. Um, yeah. So given this information, it seems like the queue or the system that we're concerned with is the warehouse. So given that, likely yung pinakamalapit na reasonable um reasonable clue dito, a reasonable system is yung uh, yung arrival niya is Poisson distributed, so this is M. Yung serving niya is general lang, so D. M, G, infinite, GD. Yan. So this is likely the system that we are considering. I guess another possible one you could consider is M, M, S, G, D, K, infinite. The special case where K is equal to S. But ultimately kasi, from a solving perspective, this is quite harder to do. And essentially kasi yung mangyayari is, well, una, it says here there's no limit to the containers that the company uses for aging. So that's your first clue. Hindi na to pwede. So this is essentially infinite. But also yung key mo is, kasi essentially you'll have unknowns. Like you'll be solving for multiple unknowns at the same time, which just doesn't make sense. At least in this problem. So, and essentially yung mangyayari is you'll have a really large k equals s. So at this point, it just makes more sense to have it as infinite. So yeah, that's generally why we're going with this queuing system. Why we're going with this parang queuing system template. So ayan. Then moving from this, what we can do is, so yung tinatanong is, how many warehouses should the company have to sustain its production reliably? So the question is, how many is it holding in one place? Kasi yung tinatanong lang pretty much is the size, how many warehouses we should have. So the question is, how many, if hindi constrained yung warehouses, how many are they producing? So to find that, we just have to get L. So that's the number of bottles in the system. So we can solve L. Thankfully, it's one of the easier formulas now. L is just equal to lambda over mu. And this is just equal to lambda natin is 2 per day. What I like to do is I list down the units as well kasi reminds me na like especially kung unit of time siya, mapapansin mo, and that's where you do the reciprocal 1/50 years. So remember, technically 50 years yung nakalagay dito. So 50 years, and then dun ko mapapansin. Okay, reciprocal dapat. It's 365, 730 divided by times 50. So this is 36,500. So that's your L. Yung final twist dito is each warehouse can hold 3,500 bottles. So we just have to divide that by 3,500 and we get 10.4285. So warehouses needed. Obviously, I think it makes sense to round up in this case. So, yung nakuha nating sagot is 36,500 over 3,500. Round up, there's the round up function, which is equal to 73 over 7. And this is equal to 11 because it's 10.4285. So yeah, that's the answer. So pretty much that's the answer that's the answer we're looking for. Relatively straightforward lang naman. Yeah. So that's for problem 2. Rechecking lang. Yep. So moving on, problem 3. An amusement park has a unique attraction. Each jetpack can be used by one customer only. Just be better to highlight everything. And there are only 3 underwater jetpacks available at any given time. Each time limit for the usage of each jetpack is not strict. It depends on the instructor's mood at a given time. It has been determined to follow an exponential distribution, mean of 30.2 minutes. Customers wanting to try this attraction out arrive at the rate of 30 per hour. However, the holding area for this attraction has space for only 2 people waiting for their turn with a jetpack. Arriving customers when the holding area is full are told to come back later, so they don't enter the system. So una, model this process as a queuing system, give the Kendall notation and the transition diagram. So, okay, essentially, we have one. So we can first define yung Markov chain natin. Let x of t for all t be the number of users in the system. So, that means na it will range from 0 pag walang tao to 3. So, magiging 3 kasi number of jetpacks plus the holding area. So, magiging 5. Okay. Then, okay. Then, yung mangyayari is the arrival, if we look at it, really doesn't change naman between the states. Yeah, it doesn't change between the states, and the reason for that is di naman dependent yung arrival rate on how full or how empty the system is. So our lambda is all the same. It is at the rate of 30 per hour. And then yung uh yung serving rate natin will change because you have multiple servers. So in this case, let's just look at it. Average mean of 3.2 minutes. So I guess get the reciprocal para lang malinis siya. Let's convert the actual fraction. It's 5 over 16. This is per minute. If they have 2 jetpacks in use, we'll have to apply merging property. Oh my god, lumalakas yung ulan. Sana di mag-blackout. But anyway, I guess let's wrap this up. So 5 over 16, kung dalawa, magiging 10 over 16, right? Because using our merging property, there are now 2 jetpacks that could finish at any given time when there are 2 in use. So magiging 10 over 16. Again, minutes sa bottom here. So 10 over 16 per minute. Dito naman, tatlo. So magiging 15 over 16 per minute. In the holding area, hindi mag-change. If there are four people in the system, there are three jetpacks in use and there's one person waiting in line, meaning hindi nagbabago yung number of servers after this point. This is just 15/16 as well. And pati yung dulo. Because at this point, pagdating mo sa state 4 and 5, hindi naman nag increase yung number of jetpack users. Okay. All right. Wait. Okay. So now, what we that's pretty much it. I guess for the sake of completeness, let's convert this also. So magiging 1 hour over 60 minutes. So magiging 1/2. Dapat di ko na pala sinulat. 1/2 minute. Pero the previous answer is, I guess, correct naman. Pero it's just more complete. 1/2 per minute. Yeah. Okay. So that's done. That's pretty much the queuing system. Then the notation is just arrival process is Markovian, serving process is Markovian because the given states it's two people, 30 per hour. And the default assumption is that it's Markovian unless otherwise stated, at least for this LE. It says also that the time limit is follows an exponential distribution with a mean of 3.2 minutes. So Poisson process rin siya. So three servers, three jetpacks, FCFS because there's a line, and I guess default assumption ulit. System capacity is 5 because there are 5 people that could be using the jetpack or in the holding area. So K plus C, and then infinite because wala namang stated limit on the number of users. Okay, so that's A basically. Mukhang okay. Hopefully it's working. Na-paranoid ako. Kasi walang audio yung kahapon. Part B. What percentage of the time are there no jetpacks being used? So this is just P0. Pulling up our equations. This is MMS, FCFS, uh, K infinite. So this one. Where P naught is just 1 over P0 until C0 until CK. Okay, so let's just calculate. Yung individual C values natin. So your C0 is obviously 1. Your C1 is 1/2 over 5/16. 1 divided by 2, 5 divided by 6. 8/5. C2 is 8/5 times 1/2 over 10 naman, over 16. 4/5. C3 is 32 over 25. Just the previous value. Calculate ko na. 32 over 25 times 1/2 over 15 over 16 is 8 over 15. I'll leave that as is kasi di ko na yun kaya i-mental. Times. Well, at this point, ano lang, kasi constant na siyang 8 over 15. So, it's 8 over 15 squared. Eight over 15 cubed. So that's our C values. Now we just have to add them all together. So, i-shortcut ko na lang. 1, so it's the non-repeating part. 1 plus 8 over 5 plus, but this part starts repeating na because may 8 over 5 plus 8 over, yeah, tama. Oh shit. This is so 8 over 5 plus 8 over 5 times 4 over 5, so just 8 over 5 times 4 over 5 plus times 8 over 15, and then we can raise this to x. Wait, I'm trying to save this faster. This is from 0 to 3 because 3 times magre-repeat yung 8 over 15. Oh, what? Or, what ko ba ito ginawa? Sorry. No. Times. I think it would have been faster to do it normally. Okay, so we get this number. Let's save it. And then, okay, so this is the sum of the denominator term, and then we can get P0 by just getting 1 over that. 0 point. So, tanong is what percent of the time are there no jetpacks being used? So it's just this is just equal to 0, result and percent na, parang mas mabilis. 19.5277%. So that's pretty much your P not. I'm gonna save that for later. It's useful. Next, okay. Next up, we're gonna get the percentage of time where all jetpacks are being used. So that's just P3 plus P4 plus P5, right? In that case, okay, let's go. So we have P0, so it's just a matter of finding P3 plus P4 plus P5. So we also have values on ano. So what I'm gonna do is just C0, ay, P0. Kasi diba, Pn is equal to, what the hell? Pn is equal to Cn times P naught. So just to speed this up a bit, what I'm gonna do is P naught C3 plus C4 plus C5. And I guess you could even take this a step further. Because diba, C3 is just, C4 is just C3 times yung lambda over mu, transitioning from 3 to 4. So you could, I guess, if you really wanted to save time, you could take this a step further. It's just C3 1 plus uh 8 over 15 plus 8 over 15 squared. So let's do that just to demonstrate it. So this is P0 that you've saved times C3, which is 32 over 5, 25 not over 5, times 8 over 15 times 1 plus 8 over 15 plus 8 over 15 squared. I don't know how faster this is. I don't even know if it's faster in general. Pero ayan. That's our final answer. So again, let's just represent this as a percentage, as the problem asks for. 24.2326%. Again, you could just solve it like normally. Parang medyo OA na yung i-breakdown mo pa. But I think it's a bit faster. No idea. Especially if you forgot to save the C values. So that's for C. For D, what is the average percent utilization of the jetpacks? In this case, this is just a matter of multiplying the associated percent utilization with the associated probability. So in this case, let's just list it all down. Siguro, number of jetpacks used. I state util percent probability. So when there are 0 jetpacks being used, 0/3 are being used. And we know this happens 0.1952% of the time. If there's 1 jetpack being used, this is 1/3. And this is I guess a good time to recover all the probabilities. Times 8/5. This happens 0.3124% of the time. And I'll do some saving now. I'll just make small marks here so I can remember where I saved them. If there are 2 jetpacks being used, this is 2/3. And this is just yung na-save natin times, mali pala. Yung A times the C value, which is C2, which is 32/25. 2499, mag-round up tayo sa magiging 25. 0.25. Approximately, obviously. Okay. And then, yan. And then 3/3, this applies when you have 3 to 5 jetpacks. This is just 1 minus P0 plus P1 plus P2. So I guess just to make it so this is just 0.2423. Save it here. So then we get B times 1/3 plus 2/3 times C plus D. Solving that, we get 0.5131098711. So what we did here, just for visualization, is times natin kada term. So thus they added them together. This gave us 0.5131. In percent, sorry. 51.3109. So magiging 10 yan. Percent. Okay. So that's the average percent utilization of the jetpacks. And then it says what is the average number of jetpacks being used. Actually, dito, we can use the general property na average number used is just equal to percent util times number of servers. So times 3. is equal to 1.5933. And that's the final answer. So that's for problem 3. For problem 4, 3 light bulbs. Wait, actually, give me a while. I'll take a short break now. Okay. Problem 4. 3 light bulbs have independent exponentially distributed lifetimes. The mean lifetime for the first bulb is 1 year. The mean lifetime of the second light bulb is 2 years. The mean lifetime of a third light bulb is 4 years. What is the expected number of months until any one of the 3 light bulbs die out? And then what is the expected number of months until all light bulbs die out? So the first one, this is just competing exponentials. This is just merging. Um, so what we're gonna do is first determine the rates. So the rate of the first light bulb is 1 per year. Second light bulb, so number of months. So let's just convert it now. So this is 112 per month. The 112 per month. So yeah. Second one is 1 over 24 months. The reason for that is 1 over 2 years, tapos 2 times doon. So, ito naman, lambda sub 3, 1 over 48. Okay, so that's the expected lifetime of each, or the rate of each, until any one of them die out. This is just merging, so we get the yan. Basically get this. Let's plug that in. Plus 1 over 24 plus 1 divided by 40 gives us 48 over 7, meaning the expected amount of time is 48.7 months in the numerator. Kasi hindi na to rate time na to, because we got the reciprocal of the rate. So that's the answer to A. For B, it's a bit more complicated because you have to split up the scenario types for how the light bulbs could die out. We have we have a lot of scenarios. We have 6 in total. So this is your start. We know until the first light bulb dies is going to be 48 over 7. This is uniform for everyone. But at this time, pwede kasi mangyari. Pwedeng mamatay yung first light bulb. Pwedeng mamatay yung second light bulb. Pwedeng mamatay yung third light bulb. So, what this means is na after this point, we have to get the expected amount of time na naman between this time and the time another light bulb dies. The difference now and the challenging part is tracking the scenarios, because if the first light bulb dies out, this is just now a merging between light bulbs 2 and 3. So mag-merge ka. And there's a chance that it's either the second light bulb dies or the third light bulb. And then after that, the one remaining. So may time ka ulit between the may isa kang light bulb remaining, then you want to get the expected time before it dies out also. So in this case, same here sa 2, pwedeng si 1 or si 3 yung next. And then yung matira, whoever that is. Same here sa 3, pwedeng si 1, pwedeng si 2, and then whoever is na yung natira. So those are your 6 scenarios kung which light bulb dies out. And kada scenario here will have different durations as well. So let's start. If one dies out, if one first death, so let's calculate yung time it takes to go from, so this time, itong dalawa, ganon to katagal. We get the merging of the two remaining light bulbs, which is 1/24 and 1/48. This gives us, luckily nandito na yan, 16 months. So I'll just go through the end of each branch, like yung pinakadulo, para it's a bit clear. So if one is the first death, it's another 16 months. So let's just add that here for tracking. If yun yung nangyari, then we have to get the probability na it's either C2 or C3 yung mawala. So in this case, we also have to check for the probability of each. So let's get the probability na it's 2 yung mauna. So that's 1/24. So A1. Second light bulb 2 dies. So 2 second death. And then this is 1/24 over 1/24 plus 1/48 is equal to 2/3. And then A2, 3 is the second death. So 1/48 over 1/24 plus 1/48 is just equal to 1/3. And you know this will add up because the way you can check is mag-add siya dapat to 1. Same thing, hindi ko pa pala pinakita. So this is for this entire branch. I forgot pala to, so yeah. Same lang naman, na baliktad ko lang yung order. We also have to consider which of the 3 die out first. Which dies out first. So this is the very first step pala. So it's basically just this process. So una, si light bulb 1, 1/12 over 1/12 plus 1/24 plus 1/48. It's 4/7. So 2 naman is the same process. Except 24 na to. This is 2/7. Because 1/24 is 1/2 of 1/12. And then keep going. And this is 1/7 if the numerator is 1/48. So that's the chance basically here. 4/7, 2/7, 1/7. And then dito, nalaman natin na 2/3, 1/3. Let's just go to the last part of this subdivision. Kapag si bulb 3 na lang yung natira, our rate is just 1/48, hindi na siya competing exponential, and therefore we know it'll last 48 months. Dito naman, we know it will last 24 months kasi si bulb 2 na lang yung natira. So yeah. Next, in the case where bulb 2 is the first to die, we have to check kung alin yung mauuna between bulb 1 and 3. So that's 1 over 12. 1 over 12 plus 1 over 48. So 4/5. And um, so this is the case where this is the chance na si bulb 2 yung unang mamatay. Ay, si bulb 1. So, for ano naman, for the other bulb, so bulb 3, this is 1 over 48 over 1 over 12 plus 1 over 48. This is just equal to 1/5. And again, they add up to 1, which makes sense. What happens? How long does it take in general? We basically just get 1 over 112, 112, yeah, 112 plus 1 over 48. And this gives us 9.6 months. Okay, the last one naman is if 3 is the first bulb to die. So let me just log all the values here. 9.6, 9.6. Because dito, it's relatively trivial na kasi it's just reciprocal. 4 years yung expected life ni bulb 3. So 48 when it gets here. So 4/5 chance, 1/5 chance. Dito naman 12 because yung bulb 1 na lang yung natira. Okay. Bulb. So yung last two na lang between bulb 1 and 2. So if bulb 3 dies first, si bulb 3, either bulb 1 or bulb 2 yung mawawala. So let's get the expected number of months before any of the bulbs die out. That's 1 over 12 plus 1 over 24. 8 months. Okay, in this case, takes 8 months, pero the question is which. So the case where it is bulb 1 is basically 1 over 12, 1 over 12 plus 1 over 24. Two-thirds, C2, bulb 2, second death, 1 over 24 over 112 plus 1 over 24. 1/3. So, yan. Basically, it adds up to 1 as per expected. And that's all our can complete this table na essentially. So, 2/3, 1/3. 8, 8. And then, pag si 1 yung una nawala, bulb 2 will take 24 months because this is just the reciprocal of 1 over 24. And then, if si bulb 2 yung nawala, si bulb 1 naman will take 12 months. So, essentially, we now have our scenario splits. So what are we gonna do with that? I'll just move this. I'll just make a separate copy. Oh shit. Right. Okay. Sige. So now we tabulate this. So we have 6 scenarios. The first scenario is essentially uh wait, 48 over 7. So essentially we can have 6 scenarios here. The first scenario, we take the duration times the probability na that will be the scenario. Right? The duration of that scenario times the probability. So let's just take so scenario, and I will label it by the order of death, and then the probability, and then the duration. In this case, the scenario where they die in, like, I guess yung expected order, right? Because uh bulb one is the expected, like generally you expect ito yung una mawala because it has the shortest lifespan, and then two, and then three. So this is, I guess, your pinaka expected. The probability is 4 over 7 times 2 over 3, and then the duration is 48 over 7 plus 16 plus 8. The second scenario is 1, una si 1 ulit, but it's this time 3 and then 2. 4 over 7, 1/3. 48 over 7 plus 16 plus 16 plus 24. And then third scenario, 2 yung una, and then 1 and then 3. This is 3 over 7 times 4/5. And then this is 48 over 7 plus 9.6 plus 48. And then 231. 3 over 7 times 1/5, yung probability of it happening. And this is 48 over 7 plus 9.6 plus 12. Uh, okay, let's keep going. 312. This is 1 over 7 times 2/3. This is 48 over 7 plus 8, 8 months, plus 24. And then 3 to 1, 1 over 7 times 1/3. 48 over 7 plus 8 plus 12. Ayan. So I guess the fastest way to solve this is by spreadsheet. So let's log everything. I guess I said these are 5 pieces of information. So we can pretty much, if you have the class with 5 rows, 5 columns ito. So you can pretty much just log them individually and then use the function to multiply. 4 over 7, 4 over 7, 3. Oh. 4 over 7, 3 over 7, 3 over 7. 1 over 7, 1 over 7. And then 2/3, oops, 2/3, 1/3, 4/5, 1/5, 1/7, ay, 4/5, 1/5, 2/3, sorry, 1/3. And I guess one way you can check if tama yung ginagawa mo so far is you can sum them together. You can multiply them together. So let's do that na lang din here. So we can repeat this. So A1 times B1. And then we can output this across range C1 to 6. So you can see na-multiply na lahat automatically. And then we can take the sum of that. Sorry. C1 to C6. Okay, so as you can see, lagpas siya ng 1. So may discrepancy in how I did the how I did the calculation. So I will just check that real quick. Wait. So check ko lang. Okay, the fuck. 2/3, 1/3, 4/5, 1/5, 2/3, 1/3. Okay, just checking ulit. Because this should add up to 1 naman. Ah, okay, that's why. Okay, okay. Pala, because this has to be divided pa. Ah, okay. Does have to add up? Feel ko I'm missing something. Pero these are the correct calculations naman so far. Should they add up to 1? Yes. Oh, okay. I think I know what happened. It's not 3/7. Okay. So I made an error here. It's 2/7, not 3. My God. So this affects this part. Yeah. I mean, even though it's convoluted, medyo I stand by doing this kasi, ayan, kung may isa kang mistake sa given or sa nakopya, you can just change one small thing and then the calculation will redo itself. Ayan. Yeah, I'm coping. Yeah, nag-add up na siya to 1. Buti na lang napansin natin. Before we proceeded further, that's the probabilities of each scenario. Here on a separate, ano, we can write down the tawag niya, the duration naman. So this is just, you can just use fill value here. 48/7 for all 6 scenarios. So counting 8 cells lang, that's 8 to 13. 8, 9, 10, 11, 12. Yeah. So ayan, that's 48/7. And then we can just add 16, 16, 9.6, 9.6, 8, 8. And then we can also add 8, 24, 48. So I'm just adding these values, 8, 24, 48, 12, 24, 12. So just essentially doing the adding like simultaneously. So then we can do A8 plus B8 plus C8, D8 to D13. Because that will replicate yan, yung operation across all the cells. So ayan, we've added everything. And then, uh, so this one is a bit more challenging. Basically, take the probability of the scenario times the duration of that scenario. So we have to align D8 and C1. So dito, C1 times D8. So pwede naman to kahit hindi sila magka-align. So this is E1 to E6 and it'll same, parang it works the same as Excel pretty much. So ayan. So this is now parang the weighted probability of each scenario. So multiplied everything. And then we just add them together. Sum E1 to E6. Ayan. Check ko lang if I do not make any error. Oh, okay. This is short by a few months. Double check natin. 6.8 plus 8. Hmm. So check naman, this adds up to 1. Wait lang 16, 9.6, 8. Okay, just give me a bit. C1 times D8. Tama ba? Yeah. Hmm. Okay, this is ano yan? 48 over 7. Tama naman. So, wait lang for 6.857. 16 plus 8. 16 tapos okay. Okay. 48. Ah, mali yung nakopya kong given. Ulit. Wait. Kasi if 3 is the first to die, dapat pala, ano, dito 8, 48. Sorry. Yan. So then, tama yung, wait, just double checking. 48, 24. 48, 12, 24, 12. 12, 24. Hmm. It's another error. Wait lang. What the hell? 2.8571. Tama naman, 2.8571 times 0.8. So the order is 48, 12, 24. This should be the, ano naman. Wait lang, sorry. Huh? 1.4, 5.714, 2.827, 1.4286. Tama naman ah. Mali ba yung ano? Genuinely feel like this is a mistake, so I added everything correctly naman. Okay, tama na pala to. 57.2571. Okay, this is correct na. To get more decimals, we have to do ito. Wait, para mas malinaw. So grab function, click here, and then it'll give you more decimals here. So this is just to put this on paper, times ito plus. So essentially you're just getting a sort of weighted average. The probability of each scenario times the duration associated times ito plus times plus times. Okay. So now the answer to this is just 57.2571 months. Just the final answer. So yeah, that's for problem 4. Okay. Problem 5. Dual parts are produced by combining single parts. This means that the processing of single parts will only occur if there are only two of them in line waiting for an available server. Uh, Currently, there are two servers capable of processing single parts. Each server can combine two single parts into one dual part. The time it takes for one server to produce a dual part is exponentially distributed with mean of 5 hours. Single parts are loaded into the system following a Poisson process with mean 0.8 per hour. However, the workers that load single parts may opt to outsource production of dual parts and therefore choose not to load them in the system. This happens with the probability of n equals to n over 2 for n equals 1, 2, where n is the number of single parts waiting to be processed, aside from those being combined into dual parts. Una, model this as a queuing system, draw the Markov chain transition diagram. Then second, what is the proportion of time both servers are being used? Okay, so let's go. Una, we have to model this as a queuing system. So it's a bit different. Okay. Oh, the hell? Let x be number of single parts. The reason why we're choosing to represent single parts is because if you have one dual part, like in the system, that really doesn't tell you how many single parts there are. Like kasi if you have, for example, one single part, one dual part, that could mean that you have two dual parts, so sakto, or three. Kasi may isang sobra. So you can't really model that if you use the perspective of the dual parts. So that's why we're using the perspective of the single parts instead. Okay, hope that makes sense. Now we move on. So um, so now we have to check kung ano yung capacity ng system. Yung sabi dito is they will not load them in the system beyond waiting time, which tells us na nag-iiba yung arrival rate depending on the number of parang excess waiting. So we have to first find the limit of the number of servers. So this case is a bit different, right? Kasi it takes two single parts to make one dual part, meaning si isang server can accommodate two dual parts, and therefore we can accommodate up to 4 without any waiting. So hanggang 4 siya, yung capacity ng servers technically, because the server can handle 2 single parts at the same time. Right? Sorry. Tapos, essentially, now we look at the number of uh, the maximum of the system. Kasi sabi dito, the workers that load single parts may opt to outsource yung dual parts. So therefore, di sila maglo-load ng single parts. This happens with the probability of n equals n over 2 for n equals 1, 2, etc. where there are waiting single parts. So hanggang 4, walang single parts waiting to be processed. Right? Kasi they're already being combined up until state 4. Beyond state 4, however, may waiting na. So meaning, yung probability na, let's say at state 5, the probability that they will not load is 1/2. Right? And I guess just to illustrate this, ilalagay na rin natin yung transition rates. So, loaded 0.8 per hour. So, 0.8 lang pala. Lambda per hour. 0.8, 0.8. And then, beyond this point, may ano na tayo. Probability is equal to n over, so yung probability mo is 1 over 1/2, which is just 1/2 times 0.8, right? Because they basically don't load into the system with the probability of 1 minus 1/2. They don't load with the probability of n over 2. And therefore, they load with the probability of 1 minus n over 2. So this just becomes 0.4. And then dito, kunyari kung may state 6 ka pa, 1 minus 2 over 2 times 0.8, but this is just 0. And therefore, there's no point including this anymore because you cannot get to state 6 from state 5. So hindi na siya queuing, wala na siyang birth-death process. So ayun, out na yan. Now let's look at the serving per hour. Sabi, it takes time for one server to produce a dual part exponentially distributed to the mean of 5 hours. So getting our, for s equals 1, our mu is basically 1 over 5 hours. So tama na per hour. Same na siya sa serving, sa arrival. So pwede na. Pero the problem is, hindi lang to pa ganito, right? Hindi siya straightforward na ganito. Because the nuance of the problem says that it requires single parts can only occur if 2 of them are waiting in line for an available server. So here, we have to start at 2. After ma-process na yung dalawang duo parts, dalawang single parts into a duo part, wala na tayong single parts. So it's 2 straight to 0 at a rate of 0.2. Now, next up, sa 3. Ilan yung servers dito? The answer is 1, and the reason for that is, kung may tatlo ka, one server will take 2 of the 3 and then process it. After the end of the process, magiging 1 na lang siya. So meaning, 3 to 1 siya with one worker occupied during the process. Okay? Next up is 4 to 2. In this case, 4 na yung free. So, dalawang workers yung nag-work. Therefore, you use merging na. So, magiging 0.4. Same thing sa 5. 2 workers working. So, merging property. 0.4. So, this is your state diagram. I'll leave that there for illustration purposes. Pero yan. Basically, ito yan. Ito yung process mo. So, this is the queuing system. And this does not have a Kendall-Lee notation because it's not. I actually don't know if this technically doesn't have, pero it doesn't behave like yung typical natin na may equations na queuing system. So I guess even if there was, it wouldn't be a point. Slash, it wasn't discussed in class. Basta walang applicable na notation dito. Or at least one that would be useful. So that's for the first one. Second, what is the proportion of time both servers are being used? So this is just finding P4 and P5 actually. So basically find P4 and P5. No? Uh, we now have to use our traditional equations. Oh, okay, wait. So mag-move back pala to ng isa. Sorry. Last clarification. Because from P4, there are 0 waiting to be processed. So 0.8 pa pala to. From P5, magiging 1 minus 1 half na siya times 0.8. So magiging 0.4. And then from 6 to 7, magiging 1 minus 2 over 2 times 0.8. Doon siya magiging 0. And then that's when you exclude it. So from 6 to 4, meron pa rin palang 0.4. Okay, that should be the last. Sorry, guys. So P4 plus P5 plus P6 yung hinahanap natin because that's the proportion of time that the servers are being used. So we have to do balance equations for this one, yung mano-mano. So recall for balance equations, essentially you have to first get, so yung pinakauna, is basically just the first balance equation is that all of the probabilities or the quote-unquote steady state probabilities should be equal to 1. And then the second is uh you get the rate in, right, times the parang tawag from the where it came from, so the origin. So rate in to times the rate out, which is also just the rate times p of the origin, p origin. So let's start. So you get this state by state. So let's start. What I'll do is I'll just get a copy of this para may reference ako sa gilid. Really smart. Yeah. Okay. So, okay, let's go. So, state 0, papasok, you have 0.2 times P2. Palabas, you have 0.8 times P1. That's the first one. State 2, at state 1, you have 0.2 na papasok from state 3. And then you also have 0.8 from P1, from P0. So this P, not P1, this P0. Shit. Clarifications, P0. And then equal sa palabas na, which is 0.8, heading from P2 to P3, so P2, P1. P1 to P2. So ito yun. For state 2, may papasok ka na 0.2 from state 4 plus papasok na 0.8 from state 1. This is equal to 0. P4, P1. 0.8 palabas naman from state 2 to state 3. And 0.2 from state 2 to state 0. So you have 0.8 plus 0.2 P2. State 3, papasok kay state 3, 0.4. Yung 4 to 2, 0.4 na lang pala. Sorry. 0.4. 0.4 from state 5 plus 0.8 from state 2. This is equal to yung palabas from state 3 is 0.8 plus 0.2 origin state 3. And then state 4, 0.8 from state 3, 0.4 from state 6. This is equal to yung palabas from state 4, which is 0.4 plus 0.8. So yung 0.4 papunta kay state 2, yung 0.8 papunta kay state 5. So this is 0.8 plus 0.4 E4. Next, state 5. May isang papasok, 0.8. E4 equal to 0.8 plus 0.4 P5. So yung 0.8 goes from, wala na pala. Di pala 0.8, 0.4. 0.4 goes from state 5 to 6. 0.4 also goes from state 5 to state 3. Lastly, state 6, 0.4 from P5. Yung palabas niya is 0.4 to P4, origin P6. So those are 6 equations plus the normalizing, which is just P0 plus P1 plus P2 plus P3 plus P4 plus P5 plus P6 is equal to not 0, equal to 1. Now we have 7 equations and 6 unknowns. So this is a solvable system because we have more equations than unknowns. But it's a bit hard, right? Kasi di siya plug in sa calc. So the way we're going to plug this, fix this is we take first the equation 6 by just make this equation 7 by EQN6. So looking at that, P5 is equal to P6 by equation 5. We also see that P4 is equal to P5. Let's keep going. Substitute. So using this info, using this on equation 4, we get, so P6 plus P3, 0.4 P6 plus 0.8 P3 is equal to 1.2 P4. Okay. So we know that P6 and P4 are equal, right? Because the implication of this is that P6 is equal to P4. Using this on equation 4, we can basically simplify it further, meaning 0.4, let's just say P4. Let's convert everything to P4. 0.4 P4 plus 0.8 P3 is equal to 1.2 P4. Cancel, cancel. Magkakaroon ka ng 0.8 P4 is equal to 0.8 P3. And well, same din pala. P3 is equal to P4. So now we have so many of them equal to each other. And therefore, so the conclusion here is that P6 is equal to P5 is equal to P4 equal to P3. Applying this, using this on equation 2, on equation 3. So now, we've brought it down. Nagamit na natin yung 6, 5, 4. So we have 3 equations plus the normalizing. So this is actually now, the system is now 4 equations, 3 unknowns. Ay, wait lang. 6, 5, 4, 3 is no known. So essentially, we have 4 equations, 3 unknowns, which is a bit overkill. Wait, really? Yeah, 6, 5, 4, 3. Okay, so 6, 5, 4, 3 is known. 2 and 1 na lang yung hindi. 2, 1, 0. So, may 4 equations. Tama pala. The 6, 5, 4, 3 is known, and then 2, 1, 0, 3 unknowns. So 4 equations na lang. So now we can use our calc for this. So, una, we can pretty much use any equation you want here. Pero let's use the ones na kayang ma-simplify onte. So, let's use equation 3. Equation 3 gives us, so let's simplify all into P3. So, all into P3. So, magiging 0.4 P3 plus 0.8 P2 is equal to P3. So actually, this gives you the relationship na 0.8 P2. Well, okay, let's just do it yung sa calc na kasi 4 equations. 5 equations na lang siya, so we can just pick which we want to use. So I just clean this up a bit. We'll get negative 0.6 kasi 0.4 minus 1 plus 0.8 P2 equals 0. Plugging in to 2, we get 0.4 P4 plus 0.8 P1 minus P2. So, transpose lang yan for P3. Let's convert it to P3. 0.8 P1 minus P2 equals 0. Using equation 1. Well, it's pretty much what we need na. Right? Di may P0 pa. So, P3, P. This is 5 equations for unknowns. So, let's use one more. Yung sa 1. 0.4 P4 P3. So, magiging P3 siya. Plus 0.8 P1. Oh, wait, this is the same exact one. Sorry. Nalito ako. Equation 1 is 0.2 P3 0 point plus 0.8 P0 is a minus 0.8 P3. Tama ba? Mabasa. 0.8 P1 equals 0. And then let's use our normalizing equation na P0 plus P1 plus P2. But in this case, 4 P3 is equal to 1. So ito na yung system natin. Just cleaning it up for alignment. 0.8, 1, 1, 1, 4, 0. So like, linilista lang ko lang yung coefficients in the same column. P1, P2. Okay. P0, P1, P2, and then P1, P2, P3. Ito naman 0.8, negative 0.6. Okay. Simultaneous equations for 0, 0, 0.8, negative 0.6, 0. Equals pala nito. 1, equals 0. 0, 0.8, negative 1, 0.4, 0, 0.8, negative 0.8, 1, 1, 1, 4. Okay. Wait. Parang something's off. Sorry. This is off somewhere. Let me just double check my inputs. Then. Mhm. P4. So state 3, 0.4 P5. This should be, wait, 0.8. Okay, 0.2 P3. Oh, wait. Okay. P3. So magiging negative 0.6 to. No, what the hell? Wait. Saan na naman to na mali? 0, 0. Wait, state 1. 0.2 P3 plus 0.8 P0. So this is 0.8 P1. Okay. So then this is 0.2. Okay, better. So, and sorry, error lang sa pag-copy ng equations ulit. So, Solving this gives us P0 equals 3 over 86. P1 is equal to 7 over 86. P2 is equal to 6 over 43. And then P3 which is equal to P4, P5 equal P6 is equal to 8 over 43. Meaning to get yung pinahanap lang is ito. So therefore P4 plus P5 plus P6 is equal to 24 over 43. Or this is also equal to, ano yung tinatanong dito? Proportion of time. So, okay na yung 0.5581. It's your final answer. And so that's it. I hope this was much better. Hopefully it was much clearer as well. Okay. I think that's a wrap. Sige. Thank you.